Hello, today we are going to be talking about what the different kinds of plate boundaries actually are and what happens at each of those kinds of boundaries. So, you have probably heard of these before. This is hopefully familiar to you. There are three types of plate boundaries. The first is divergent, and these are where plates are moving away from each other. Divergent divide, they are pulling away. This happens when there is a weak zone, a particularly thin part of the lithosphere in the crust, and some magma is rising up beneath that crust, which makes a plate crack into two pieces. The tectonic plates that we have now are not set in stone, so to say. They can break apart into smaller pieces, and so a plate can crack in half, and they move apart, and that becomes a divergent boundary. Lots of times you find these along mid-ocean ridges underwater. So the Mid-Atlantic Ridge is a well-known mid-ocean ridge where the seafloor is spreading. The seafloor is moving apart from each other. So we can see down here there is a weak spot in the crust where magma has pushed up, leading to a ridge, kind of almost like a low mountain on either side, and a gap in the middle where new crust is being made. That's the key thing with divergent boundaries, is that new crust is being formed. This is why oceanic crust is often younger than continental crust, because these things most of the time happen underwater. This new crust, where the crust is thinner in the ocean, it breaks, it starts to move apart, and new crust forms to fill it in. So this thin, young crust exists in the ocean. We can see this starts to happen in the middle of a continent. There's a weak spot, or in the ocean, and it'll start to rip apart, and you'll get a rift valley as it is being pulled apart, but not all the way separate yet. And since that is lower down, it is a valley, water will fill it in, and we will get a shallow sea. And then eventually it spreads all the way, it continues to spread, and you get an ocean and the mid-ocean ridge in the middle. We can see all of these stages happening, even though this happens really slowly. Plates move about as fast as your fingernails grow, or 1 to 10 centimeters a year. So they're moving really slowly, and it's hard to observe all of this happening at once over time, but we can see each of these different stages in real life. So that first stage, where it is slowly starting to crack, that's happening in the Rio Grande Rift Valley, kind of near Santa Fe or near Albuquerque. We can start to see a crack and a valley starting to form. Then a true proper rift valley, where there is now a valley in the ground and plates are starting to spread apart in earnest, is happening in the East African Rift Valley. So you might have noticed on the Discovering Plate Boundaries that there are a lot of volcanoes in East Africa, but there's not a plate boundary there. Yet, the African plate is breaking into two pieces actively. And so the main, or the Nubian African plate, and what is being called the Somalian African plate are currently actively separating from each other. So there are lots of volcanoes and earthquakes in this East African Rift Valley, where the African plate is breaking into two different plates. The Red Sea is an example of a linear sea. That's stage 3. So the Arabian plate here was once connected, was a part of the African plate, but again, a weak spot started to spread apart. And so this along the Red Sea is a divergent boundary where water has filled in the Rift Valley and is slowly expanding. And then the Atlantic Ocean is kind of stage 4. This is where we see that seafloor spreading. North America and Eurasia are moving apart from each other. The Atlantic Ocean is getting bigger because right in the middle there is this mid-ocean ridge, and they are being pushed apart or pulled apart, and a new crust is forming in the middle. So even though this happens really slowly, we can see all 4 stages happening on the Earth right now. The second kind of plate boundary is the transform boundary. This is the one that a lot of people have trouble remembering because it doesn't rhyme like the other two. Transform are where plates are sliding and grinding past each other. This does not have any big effect on creating or destroying crust. So you're not getting any new crust like divergent, and you aren't destroying crust like at convergent. The plates are just grinding past each other. Most transform faults happen on the ocean floor, but there are some on land. The San Andreas Fault in California is probably one of the most well-known examples of a transform boundary. These do happen at faults. This is how faults form. And the 2010 Haitian earthquake, which was a really big earthquake, occurred along a transform fault between the North American and the Caribbean plates. So at these transform boundaries, like the San Andreas fault is a transform boundary between the North American and Pacific plate. But most of these boundaries are more complicated than just a single type. And the boundary between North America and Pacific is more than just the San Andreas fault. It actually includes all three boundary types. So we have some transform, some sliding happening around San Andreas and along the coast of California. We also have some subduction going on. So we've got a convergent plate up north, and then we also have some diverging in the Gulf of California, which is actually getting bigger. This is a divergent boundary. So lots of times you'll see that boundaries, especially when you look at a boundary map, it's not just you can say the whole North American Pacific boundary is transformed, because that's where San Andreas is. There's little pockets of each along all of the boundaries. Transform faults often happen where there is divergent boundaries, so along fracture zones. So lots of time the mid-ocean ridge isn't actually a nice straight line, but there will be little pieces of transform in between chunks of divergent boundary. So the seafloor is spreading, but one side is spreading slightly different than the other side because the magma welling up isn't all coming up at the same speed. So you'll get a little transform fault in between these divergent boundaries. So most of the mid-Atlantic ridge is a divergent boundary where the ocean is spreading, but it's got a lot of transform faults in between these sections of seafloor spreading. Then the third kind of boundary is convergent. This is where plates collide and smash into each other. We've learned that plates have different densities and crust has different densities. So here, the more dense plate will go under the less dense plate. This is a process called subduction, which came up when we talked about convection currents. The more dense plate will move under the less dense plate, but then it's moving deeper into the earth where it is getting hotter. So eventually this plate that is subducting, that is going down, is going to melt and be absorbed back into the rock cycle. So at convergent boundaries, we are destroying plates. Crust is being destroyed as it goes down. And since it's melting, some of the magma that is melting is going to rise back up and become volcanoes as we go. So convergent boundaries, we've got crust going under other crust. But remember, crust comes in two types: oceanic, which is mostly made of basalt, and continental, which is mostly made of granite. And hopefully you remember that oceanic is more dense. So we can have these three different types of convergent boundaries. We can have where a continent meets an ocean, where a continent meets a continent, and where an ocean meets an ocean. It is important to know that for any type of convergent boundary, the more dense plate is going to subduct and crust is going to be destroyed. Those are true no matter what kind of convergent boundary you have. But let's look at each one individually. So a continent ocean, like we said, like hopefully you remember, ocean is more dense than continent. So the ocean is going to subduct under the continent. The ocean is going under the ground, or the ocean plate, to be clear, not the water. As it goes under, as it subducts, it is going to kind of buckle and bend, and forms deep ocean trenches. So all of the deepest ocean trenches, like the Mariana Trench, are forming where a piece of ocean crust is subducting under a piece of continental crust. Once it reaches a proper depth, once it gets hot enough, the ocean plate is going to start to melt, and some of the magma from that ocean plate will rise up and form volcanoes. Because this is moving kind of diagonally, as it melts, it is moving in and down. The volcanoes that rise up will not be directly on the coast or not directly on the boundary. The volcanoes are going to be to the side a little bit. They're going to be more inland because, again, this ocean plate that is subducting is moving in and down, and it moves inland under the continental before it can melt fully and form these volcanoes. So you get deep ocean trenches and volcanoes a little bit more inland at a continent-ocean boundary. Some examples of this: the Andes Mountains and the Cascades in the Pacific Northwest. Both of those are continental volcanic arcs that formed at a convergent continent-ocean boundary. Continent. Here we have two things that are both pretty low density. So one of them is still going to subduct, one will still go under the other, but not nearly as much. This is more like two things slamming into each other, and one of them's going to buckle and give and move under the other, but they are slamming into each other and mostly pushing up. There's going to be a lot of fracturing, crumpling, buckling, all of those kinds of things happening at this collision. And that is where we get the largest mountains in the world. So subduction is happening, but not as much. Really, you get these two plates. Neither one of them want to give, neither want to move under. So they're going to crumple and just make a big mess. The Himalayan mountains formed this way. That was at first an ocean continent collision, but eventually the ocean was entirely subducted and disappeared. And so now it is a continent-continent collision. And that collision is still ongoing. The Himalayan mountains are still growing as India continues to slam into the Eurasian plate. And they grow a couple of centimeters or inches a year. The Appalachian Mountains in the eastern United States are an ancient example. Clearly, the Appalachian Mountains aren't on a plate boundary anymore. They're kind of in the middle of the North American plate, which includes some of the Atlantic Ocean. But way back in the time of Pangaea, the Appalachian Mountains formed at a continent-continent boundary. Then the third kind of convergent boundary is ocean-ocean. Both of them are high density, but one of them is going to be a little bit more dense, and so one of them will sink. Both, since they are high density, kind of want to sink. And this one is going to be very similar to the continent ocean. You're still going to have that deep sea trench, but instead of volcanoes on land, you still have that melting. There's not land for the volcanoes to be on yet because the continent is farther away. We've got ocean meeting ocean here. So the volcanoes are going to form in the ocean and eventually build up to the surface and form an island chain. So you get a deep sea trench and islands or volcanic islands at an ocean-ocean boundary. The Japanese islands, the Philippine islands, the Indonesian islands, all of those form at an ocean-ocean convergent boundary. Also the Aleutian Islands, which is the chain of islands coming off of Alaska. All of those form at an ocean-ocean convergent boundary. So those are the three boundary types. Let's quickly go over again what is the geology that happens, just the fast facts. Convergent, general rule of thumb, everything is bigger, more dangerous, scary at convergent margins. Big mountains, Himalayas, big volcanoes, the Ring of Fire. This is mostly where those volcanoes are, on convergent boundaries in the Ring of Fire. Huge earthquakes, a magnitude greater than 7, so earthquakes that knock buildings down, and the crust is being recycled or being destroyed. Divergent, you get undersea mountains at those mid-ocean ridges. Some volcanoes, but they're not going to be explosive. They're just going to be little volcanoes that well up here because a new crust is being formed. You'll get rift valleys like in East Africa and some small earthquakes, but new crust at sea floor spreading. And then transform, where plates are grinding past each other. Nothing is being created or destroyed. There aren't really any mountains or volcanoes, but there are tons of really big earthquakes. Lots of greater than magnitude 7 earthquakes. And those are the three boundary types and the geology, or what happens at each one.